this stuff. She really, really likes to do this stuff. Miss Warren's, yep. So you just ask her and she'll help you through it. So, all right. So FOIL. Most of your problems on our FOIL today will look like this. Cosine of x plus 1 times cosine of x minus 1. They'll be conjugates of each other. Okay? So if you have conjugates, what do you know about your middle terms? They're always going to cancel. So if we FOIL this, we get cosine squared of x, outers and inners cancel, minus 1. Now, can that be simplified? Yeah, that can simplify down. I know cosine squared x plus sine squared x equals 1. So if I move these two to the opposite sides, I get a negative sine squared of x. Bada bing, bada boom, I'm done. What if I have 2 sine of x minus 3 times 4 sine of x plus 5? Now all of a sudden I'm going to have a middle term because they're not conjugates of each other. Just because the middle sign is opposite doesn't make them conjugates. They have to be the exact same thing except for the middle sign is opposite. Okay? So if we FOIL this, 2 sine of x times 4 sine of x equals what? 8 sine squared of x. My outers will be plus 10 sine of x. My inners will be minus 2, 12 sine of x. And my last will be minus 15. So then you just take care of your middle terms. What's 10 sine of x minus 12 sine of x? Negative 2 sine of x. And you just leave it as a trinomial because there's no simplifying from there. Okay? No simplifying from there. Now, if you have a quantity squared, Miss Wheeldryer taught you patterns, but no, it's not differences of squares. It's a perfect square trinomial that you're going to get. But what I was going to say is you don't have to use those patterns. Okay? When you have a quantity squared, just write it twice and FOIL. Because that's how trig works. What?
I said I was agreeing with you.
Yep. I was agreeing with you.
In a voice that sounded sarcastic but wasn't.
Okay. Very good explanation, Nathan. So if we FOIL, 3 times 3 is? So it's 9 sine squared of x. Outers, negative 12 sine of x cosine of y. You just write it like that. That's the way it is. Inners, negative 12 sine of x cosine of y. You don't have to write them in a different order. Just write them in that order. Last is plus 16 cosine squared of y. Now, our middle two terms are like terms, so we add them up. So it's 9 sine squared of x minus 24 sine of x cosine of y plus 16 cosine squared of y. Last example. Four cosine squared of x minus secant squared of x. So when you have a quantity squared, write it twice in FOIL. So when we multiply, 4 times 4 is 16 cosine to the 4th of x, because cosine squared times cosine squared is cosine to the 4th. Outers, minus 4 cosine squared of x secant squared of x. Inners, same thing. Last, plus secant to the 4th of x. Now, what's cosine squared times secant squared? Ooh, very good. Because secant squared is 1 over cosine squared, right? So these cancel, right? So these cancel each other. Because cosine squared over cosine squared is 1. So what we're left with in the end is 16 cosine to the 4th of x. Minus 4 is minus 8 plus secant to the 4th of x. Okay, so that is section 3.2. You will be assigned 11 through 22 all on that on page 172. But now we're going to do the 3.2C. So and that's going to be factoring. 172. So all these assignments for the rest of all of next week will also be on page 172. Well, maybe all. Yeah, we'll spend at least 2 more days on this. So, okay, factoring. How would I factor this? How would I factor this out? X and X. Signs are the same. They are both positive. So plus and plus. What are factors of 8 that add up to 6? Okay? So if I just throw cosines where there's an x, it doesn't change anything as far as the factoring goes. It's just like factoring with more normal letters. And if you just have a mental block when it comes to trig factoring, change your sines and cosines to x's and y's. Factor it and then apply it to your trig. Okay? So, this is no different. So here I split up my x and x. Here I split up my cosine and cosine. Signs are the same. They're both positive. factors of 8 that add up to 6 are 4 and 2. Okay? That's not so bad, right? No. Oh, 2x. All right, how'd Wheels teach you how to do this? Yeah, the AC method. The AC method. Take A times C, which is negative 15. And then what are the factors of negative 15? Well, they're 1 and 15, or 3 and 5. Now, there's opposite signs to make negative 15, right? What adds up to be the middle term? Positive 5 and a negative 3, right? So we rewrite this as 5x minus 3 and 5x plus 5. So we drop the power on this to just make it 5x, okay, and write it at the first in both, and then we write these behind both, okay? Then, what's the greatest common factor of the first two? 1, so we divide that by 1. What's the greatest common factor of the last two? 5, so we divide them by 5. So it's 5x minus 3 times x plus 1. Okay? So if you would FOIL this, you'd get 5x squared. Outers is 5x. Inners is negative 3x, which makes 2x minus 3. Okay? So if we take the same concept, I'm going to change up the numbers on you, so you have to think a little bit more. 4 sine squared of x minus sine of x minus 5. 4 sine squared of x minus sine of x minus 5. So you multiply first and last terms to get negative 20. I'm not worried about the sign right now. Okay. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Obviously, which ones are the ones that we need? 4 and 5. Which one's positive? Which one's negative? Negative 5, positive 4. So we'll rewrite this as 4 sine of x plus 4 and 4 sine of x minus 5. What's the greatest common factor of the first? 4, so we're going to divide by 4. Greatest common factor of the last is 1. So it's going to be sine of x plus 1 times 4 sine of x minus 5. If you would FOIL it, you would get that. Okay, so FOILing is how to check your answer. So that's one type of factoring that we'll do. Another type of factoring is Kendra's favorite. Tangent squared of x minus cosine squared of x. Okay? Because what is it called? Difference of squares. Okay. When you have two things that are square that are separated by a minus sign, you just take the first and split it up. Opposite signs, take the last and split it up. And you're done. Difference of squares. So that's easy. Ew. Looks a little complicated, but it'll get super easy if you see what to do.
There's something with identity.
Not identities. Nope. Absolutely, Cadence. You take out a cosine first. If there's a cosine in everything, take it out, and all of a sudden it becomes a pretty easy equation to factor. So cosine of x is on the outside, 2 sets of parentheses. Then the first term in each is cosecant of x. Signs are what? One's a positive and one's a negative. And we need factors of 3 that are 2 apart. What are our factors of 3? 1 and 3. 1 and 3. So the 1 is positive and the 3 is negative because they have to add up to -2. Okay. 2 more things and then I'm done. This is actually a little bit difficult of a problem. Okay. Couple different ways to do it, but if this has a square root and this has a square root, it's called a perfect square trinomial. What is a perfect square trinomial? It is quantity squared, where it's the square root of the first, the sine of the middle term, and the square root of the last. So it looks like that. And you think, okay, that was easy. What's the problem with this? It can be factored some more. Very good. So really, this is like this, right? What is this called? What is this called? What's Kendra's favorite type of factoring?
Difference of squares.
Difference of squares. Oh, this is secant of x plus 2 and secant of x minus 2. And this one is the same thing. Secant of x plus 2 and secant of x minus 2. Okay. So you'll have one where you only have to do one step, but then you'll have a second one where you have to do the extra step. Okay. Last thing. When you have 4 terms, such as 4 sine squared of x plus sine of x minus 4 sine of x cosine of x minus cosine of x. I think that's right. When you have 4 things, you got to think grouping. Now, those of you who are in Algebra 2 now, this is a little fresher in your mind compared to those of you who had Algebra 2 last year. Okay? I understand that. But when you do factoring by grouping, the middle sign always has to be a plus. So if it's a minus, we just go plus a negative before we put our parentheses in. We go plus a negative before we put our parentheses in. Now we're going to group the first 2 and the last 2. What's the greatest common factor of the first 2? sine of x. And I get 4 sine of x plus 1. What's the greatest common factor of the last two? Cosine of x, but not just cosine of x, because we wouldn't get matching things. So we have to take a negative cosine of x out, because what goes in your parentheses has to match or they will not regroup. They have to match. So we have sine of x minus cosine of x times 4 sine of x plus 1. Factoring by grouping. Okay, so your second assignment. Bierschbach is so mean. Page 172, 23 through 36, all. So I promise we'll only do one assignment next Tuesday. We're only going to do one assignment next Tuesday, so it won't be so bad, but you have a lot to do over Easter. Okay? So okay.